Understand the relationship between reaction enthalpy, delta H degrees, and bond energies. The enthalpy change of a reaction can be estimated by calculating the energy required to break the reactant bonds minus the energy released when the product bonds are formed. Delta H degrees approximately sum bond energies of bonds broken, sum bond energies of bonds formed. From question 36, we know that the enthalpy of this peptide coupling reaction is delta H degrees 298 equals maths plus 12 kilojoules per mole of reaction. Identify which specific bonds are broken and formed by examining the chemical structures on page 25 of the exam booklet. Reactant side, bonds broken. The C-O single bond of the carboxylic acid group, COH, in the first glycine molecule is broken to release the circled hydroxy group. 1N-H bond of the amino group, NH2, in the second glycine molecule is broken to release the circled H atom. Total bonds broken asterisk 1 times C-O and 1 times N-H. Product side. Bonds formed. A new peptide bond is formed directly linking the carbonyl carbon and the amino nitrogen, CN. The released hydroxy group and H atom combine to form a water molecule, H-O-H, creating one new O-H bond. Total bonds formed asterisk 1 times C-N and 1 times O-H. Sum the bond energies of the broken bonds. Using the values given in the table, bond energy, C-O, equals 360 kilojoules per mole. Bond energy, N-H, equals 390 kilojoules per mole. Sum, bonds broken, equals 360 kilojoules per mole plus 390 kilojoules per mole equals 750 kilojoules per mole. Set up the algebraic equation to solve for the C-N bond energy. X let X represent the bond energy of the newly formed C-N bond. Delta H degrees equals sum, bonds broken, bond energy C-N plus bond energy O-H. Substitute the known values into the equation. Plus 12 kilojoules per mole equals 750 kilojoules per mole. X plus 460 kilojoules per mole. Plus 12 is equal to 290. X solve for X and find the closest option. X equals 290. 12 is equal to 278 kilojoules per mole. Comparing this calculated value to the options, 278 kilojoules per mole is closest to 300 kilojoules per mole. This identifies option B as the correct answer. The correct answer is option B, 300 kilojoules per mole.